What if I told you you could be the owner of one of the most potentially disruptive manufacturing companies for the upcoming fourth industrial revolution? We're currently running a poll on the channel where I asked you, what types of stocks are you guys most interested in? Are you most interested in tech stocks? Are you interested in recovery stocks? Are you interested in disruptive stuff like ARK funds? Or is it like, whatever, as long as I can make money? And it sounds like most of you guys are just kind of like, whatever makes me money is cool. But interestingly, especially after the huge dip of the last couple of weeks, Desktop Metal kind of fits into all four of those categories. It's manufacturing, which typically, historically, has been a very different category from tech. But now, using AI and using all these different technologies, Desktop Metal is now kind of straddling that line between tech and manufacturing. But anyways, thank you guys so much for your participation. In that poll. Running these polls to try and get a better idea of what your needs are, what your goals are, so I can tailor the activity and the content I make more to you guys. So anyways, back to Desktop Metal, supported by the likes of ARK and Cathie Wood, Chamath Palihapitiya. They're also experiencing a huge boom in adoption by some of these companies as well. We're looking at really big companies like Amazon, Mattel, 3M, the Navy, Adidas, Dow, Volkswagen, Bosch, and a lot of really big names. So one of the fascinating things we're going to see, particularly in regards to the time point we're at right now, when we get into the financials, is that Desktop Metal isn't like the kind of stock you look at if you're one of these traditional investors who needs to see a really good PE ratio and stuff like that. But when you think about the potential for the next step, it's like, oh my gosh, I got to get in now because Desktop Metal is about to break the whole manufacturing game. And we're going to get into that today. So the third industrial revolution, which kind of started 60, 70 years ago with, the rise of telecommunications and computers, it really shifted the way humans work. It shifted efficiency. It created new jobs and obliterated other jobs, but it shifted the way the whole world operates. And we're coming up now on the fourth industrial revolution, where we're looking at things like the internet and the Internet of Things, connecting humans all over the world, and also rushed forward even more so from this huge shift to work at home as well, but also combine things like AI and 3D printing, which is where Desktop Metal comes into the picture, because they're revolutionizing additive manufacturing by basically making manufacturing way cheaper and way faster than 3D printing has been so far. And that's going to end up changing the way the whole world works. Up until recently, 3D printing has, for the most part, been limited to extremely specific applications or hobbies, and has often been finicky, high maintenance, slow, expensive, or unreliable. All of that is about to change, and Desktop Metal is on the forefront of changing the way humans manufacture. So what's so good about Desktop Metal in particular? Simply put, Desktop Metal allows for printing of various different types of materials, whether it's metal or polymer, in really, really compact situations. They have some models that fit on your desk, hence the name Desktop Metal, but they also have models that, would be the size of like a bedroom type factory that can output huge amounts of products way faster than it would be to, build something in China and have it shipped over and deal with all the customs and all the shipping and all that stuff too. And this additive manufacturing allows you to print at speeds of like 100 times faster. And Desktop Metal's new additive manufacturing 2.0 allows you to print at speeds up to 100 times faster than other 3D printing methods at 1/20th the cost. And this works regardless of the quantity you're going to be making. I'll get into how that compares to other traditional manufacturing techniques here in a minute. Depending on the application and the need, they're capable of working with polymers or metals and therefore have endless potential application. They explain that manufacturing in general has extremely specific demands, and to make a machine capable of meeting the speed, accuracy, finish, and property requirements for a vast variety of needs is only becoming available now using what they call additive manufacturing 2.0. So they show on the chart here some really specific types of machines and equipment. Down on the bottom right, I wanted to highlight finish, improvements in surface roughness, that reduce need for post-processing. And that's one of the things that's just becoming possible with 2.0, because they say that they're able to print now at much higher resolution. And so if you click down on the bottom left, the little gear icon, you can change the resolution of this video. You could go to 144p, then you'd be able to see all these huge squares, or you could go all the way up to 4K, then you'll be able to see like the individual pores on my face. So by being able to print in a higher resolution, you can print things that are really smooth. They don't have to be rough or blocky anymore. And therefore they're able to make, medical devices or teeth dentures, things like that need to be really smooth. And that's all just becoming possible now. So typically up until now, there are like many different manufacturing methods, but you might think about machining or casting or molding. I think like I have this little clock here. It has a bunch of little different plastic parts. Were probably made by molding, where you have a little mold, you pour some plastic into it and then it hardens, then you take the mold off. Now you have all of your pieces. I'm super a noob at anything manufacturing or engineering, so let me know if that's completely wrong. But machining, on the other hand, is where you might have a huge piece of metal or a huge piece of wood, and a worker or a machine basically carves that out into the final product. I think like MacBooks are machined from one big piece of metal, stuff like that. And so those different types of manufacturing have different requirements, but what you need to do before you get the ball rolling is you need to make the machines or the molds or the castings, or you need to teach the computer how to do the machining and what shape to carve it in and stuff like that. And so Desktop Metal has provided this graph here. So we have, first let's look at the right side. They say an illustrative break-even analysis versus tool-based manufacturing. So quantity of parts on the bottom line on the x-axis, and then cost per part on the y-axis. So it shows casting on the top left. So to make a casting machine, whether you end up making one part or 10 million parts, you still have to make that machine to cast stuff. And that ends up costing like millions or tens or hundreds of millions of dollars. We know that that's been a useful process for a lot of different things like making cars or whatever. But check it out here on the chart. They say Desktop Metal of today, regardless of how many parts you're making, if you have the machine, you have the machine. And so if you're making one or you're making a million, the setup is the same. The cost is the same. And then in Desktop Metal 2030, the red dotted line at the very bottom, it's going to get even cheaper. And then taking a look at the left side of the graph, we're also seeing print head drops per second. And so it's getting faster by huge factors every generation, every year. So we're seeing that not only can 3D printing be way cheaper per part, which is particularly useful when we're prototyping or making one-off tools or equipment, but we're also starting to see that print speed is getting multiplicatively faster with each generation. So while typically up until now, 3D printing has been complementary to traditional ways of manufacturing, you might be able to make a mold or parts of a machine that they use for casting using 3D printing. It seems like with these speed improvements and cost improvements, additive manufacturing 2.0 is probably going to start overtaking these traditional ways of creating products. The applications of this are endless, not only for manufacturers or prototypers, but also for small business, offices, parts departments, machine shops, dealerships, and more. You guys know me, I'm a car guy. I think in terms of cars. And when I think about these kinds of opportunities, the abilities you can get with something like this, like my heart starts racing and my mind goes crazy. Imagine you have this 68 Mustang and you just can't find any more parts because all of the Mustangs are starting to rust out and fall apart. Just print it. It's not a big deal. Or you go to Ford's parts department or the dealership who no longer has to store like millions and millions of different parts for all of the different years and makes and models and grades of every single car. They just have the schematics at corporate and they have a little printer, or not even necessarily a little one. They have a 3D printer from Desktop Metal in their parts department and they say, dude, we need this part from a 68 Mustang. Corporate sends them over the schematics, they print it out and they put it on your car and you're done. Now the dealership doesn't have to worry about shipping costs. They can provide faster service and probably lower prices. And they don't have to hold all of this stuff in regional distribution centers or in their dealerships. Another potential application for car guys like me, you could print out a new exhaust system. You're like, hey, it's getting kind of rusty. Let's make a new one. Done. Lol. You know, you could print out custom parts, even like Little stuff like, dude, the cup holder in my car doesn't fit a 7-Eleven Big Gulp. Let's make it bigger. Done super quickly. Like, it doesn't even have to be stuff that simple. It could be making new suspension parts using AI to figure out how to make it lighter and more durable. Typically, up until now, when you're engineering and designing a part, one of the restrictions is like, dude, I've designed the coolest, strongest, cheapest part ever, and then you take it to manufacturing, they're like, sorry, our machines can't do that. Now you're not limited by that. Now you can be like, let's just make the lightest, strongest, coolest looking thing ever, because the machine can just additive manufacture where it's just layer on layer on layer on layer, any shape you want. And if you had one of these desktop metal machines at home and you designed a new part, you could just mass manufacture it easily and then start selling them online, and now you have a business. And those are just some ideas when it comes to the auto industry. We're going to get into ideas that they've already started executing in medicine and in dental care and stuff like that. What are some hobbies that you have? What are some ideas that you have that you could totally like change the world with if you had a 3D printer that could crank out pieces really, really quickly that are really durable and reliable? Let me know down in the comments section. In this slide, they give us some more insight into how additive manufacturing will break the current way of doing things in this world, from superior designs that are unrestricted by the manufacturing process, customization for every piece, simplifying and consolidating manufacturing, therefore reducing cost and improving efficiency, as well as re-engineering the entire world's supply chain, little stuff like that. This is going to be happening. You no longer need to outsource manufacturing to places across the world when it's super fast, more trustworthy, and probably just as cheap when you could do it in your own living room or your own machine shop. Factories could legit be obsolete with this kind of thing. They shared a couple of case studies that are really interesting to give you a better idea of how this could really change the industry going forward. Check it out here. They have a customer who got the shop system, which is one of their systems. And this company is a supplier to Louis Vuitton, Givenchy, Aubade, and Chanel. This little company is in Bourg-de-Péage, France, and they make metal ornaments for these different companies. Check it out. They use the shop system, and it increased their leather hardware production from 10,000 pieces per week to more than 73,000 parts per week. 7x increase in production using this little machine. And it also says there on the bottom left, time needed to craft and assemble highly customized jewelry has been cut down by 250 hours to allow for 17,600 individual pieces to be created per week with no assembly needed. So for this company, this is a total game changer. And this is just one little niche supplier company that supplies all these big fashion companies. So we've talked about medical, we've talked about auto, we've talked about fashion. Like, the applications of desktop metals services are endless. Here's another case study they've provided for a medical devices producer who multiplied their production speed by 20x, and they called this a real game changer for their industry. Provided a 70 to 90% reduction in lead time, reducing the typical 12-week lead time to about 10 days. That's a big freaking difference. So essentially, take everything you know about the way things are manufactured and throw it out the window, because the fourth industrial revolution is here. But Desktop Metal isn't the only company in this space. In fact, ARK Invest has a whole fund called PRNT, and this fund seeks to invest in companies in the 3D printing ecosystem, including 3D printing hardware, software, measurement, and materials, because they believe that 3D printing should transform manufacturing by providing greater design complexity, accuracy, efficiency, and customization. Check it out here. It shows the holdings, where Desktop Metal is number 16 out of 55 of these holdings, making up almost 3.5% of the holdings in the whole fund. If you're invested or knowledgeable about any of these other companies like EXONE, 3D Systems Corp, HP, or any of these others, please let me know your thoughts on how Desktop Metal fits into this mix of competition and complementary companies. And let me know down in the comments section your thoughts on those, and if you think I should be looking into those, or even if you think some of these options are superior to what Desktop Metal is offering. So before we look at a little bit of the financials, I also wanted to mention, like I mentioned earlier, the teeth thing. They made an acquisition of a company called Envision Tech back in February. And basically Envision Tech, as they show here, was the original inventor of DLP 3D printing technology. And they're the leader in area-wide photopolymer additive manufacturing for mass production applications. And take a look over there at number 3. Complementary channels yield cross-selling opportunities in key verticals like dental, jewelry, and metal. And so I don't claim to understand all of the specifics of how these machines are going to necessarily complement each other perfectly or things like that. But when you see a young company like Desktop Metal aggressively making moves to grab complementary companies that will help them offer even more thorough offerings to the verticals that they're targeting, it shows that their management is in the attitude and mode of growth, which I like to see. Check it out. They show same day permanent full arch implant dentures, which traditionally would take 3 weeks to make. Now they can make it in 1 day, thanks to this new technology they've acquired and the new standards they're bringing into the industry. That's really game changing. They also show how that makes up an important piece of the entire desktop health portfolio, where they will be able to build up an entire arena of services useful in things like plastic surgery, dermatology, orthodontics, cardiology, otolaryngology. I feel like if the company was only doing these things, it would already have massive potential, let alone all of the other potential applications they have. But check it out. They show like an ear and a nose, but they have an entire department figuring all of this stuff out and figuring out how, like, dude, I lost my ear. Let's 3D print one that looks pretty dope. And now I can use that. Like molding it and the time to output it and figuring out measurements and all that stuff is going to be a very different process now. And not only for external pieces of the human, I think it's eventually going to start impacting like pacemakers and the way we do surgery and different bones and organs and stuff going forward as well. So that's a lot of good news. That's a lot of stuff to get excited for. And like I said at the beginning, if you're a conservative investor who likes to look at a P ratio of 7 and you like to see a good dividend return, you're going to be upset with this coming section. But if you like speculative stuff and you're a mad lad and you like to go all out and maybe, 20x your money, stay tuned. Check it out. They showed the fourth quarter and full year 2020 results. Revenue of $8.4 million for the fourth quarter and a net loss of $25 million. Bro. So they're basically saying like, yeah, we're starting to make a little bit of money, but we lost a lot of money because we're still figuring a lot of things out and we just did the SPAC and all this other stuff happened. But stay tuned. Full year 2020, revenue of $16.5 million, but a net loss of $90.4 million. Bruh. Adjusted EBITDA of minus $73 million. Good sign. Though they did show the liquidity highlights, cash and cash equivalents and short-term investments of $595 million as of the end of the year, which is a really good sign because they're not like, hey, we just SPAC'd and we've already burnt all of our money and we're in this huge mountain of debt. On the contrary, they say, yeah, we have things under control. And again, stay tuned because we're going to get into what's happening this year. So check it out here. Looking forward, they show the additive manufacturing industry to grow 11x over the next decade, from 12 billion to 146 billion. They're expecting a 25% compound annual growth rate now that they're stepping into additive manufacturing 2.0. And their full year outlook for 2021, they're expecting revenues in excess of 100 million. So they're saying we're going to do more than 12 times what we did last year in this year alone. Exit 2021 with an annualized revenue run rate of 160 million. Modest sequential growth in the first quarter of 2021, with more substantial acceleration beginning in the second quarter. And then non-GAAP adjusted EBITDA of negative 50 million to 60 million. So they're not saying we're going to be profitable yet. They're saying our revenues are going to grow big time. And as that's going on, we're going to be scaling up, which is what a small company with a lot of R&D and a lot of marketing needs to be doing. I'm not concerned by that. And sure enough, in the commentary down here at the bottom, they say significant expansion in sales and marketing, engineering, and administrative functions for organic business, and building out internal mergers and acquisition capabilities to support multiple inorganic growth initiatives. So they're really aggressive about how they're going to be able to grow going forward. Take a look at the stock chart here. Currently, we're at less than $20, but even just a few weeks ago, we were as high as $33.50, I think it was. We saw a huge dip during the last couple of weeks, this big dip where the price was basically half price. It's come back up a little bit, still not $20 yet. But again, when we're evaluating stocks like this, the traditional methods of evaluating if it's worth it or not are not really applicable. They're not really valuable and they're not really helpful because you'll probably start to see that parabolic growth kicking in. And when you're looking at companies like Tesla, where it's like not only just new cars, but it's like making the entire auto industry shift into everybody needs to have electric cars now and hybrid cars now and all this stuff. It's changing the entire game. And I think Desktop Metal is going to be doing something like that with all manufacturing, with all factories around the entire world. And so you can't calculate that in to like a PE ratio or to a current ratio or things like that. I'm really comfortable with the fact that their management team is like really stellar. And yeah, they're still showing losses, but when you're getting in on the ground floor, especially at under $20, in 5-10 years, this could be like $200, $300, $400, $500. I'm not saying that it will be. And again, this is not for the faint of heart. This is not for people who despise risk. It's definitely a speculative play. But if things play out according to their grand vision, I'm like really excited for what's going to be happening with Desktop Metal. And I know I like to always be talking about Tesla, and I always like to be comparing things to Tesla because Tesla has made a really big impact on my portfolio and my way of looking at the world over the last few years. But I think Desktop Metal could be similar to a Tesla, where it's kind of like, oh man, if we don't adapt, we're dead. So we're seeing things like Ford and Mercedes-Benz and GM and all these companies are like, okay, after 2030 or whatever it is, everything's going to be electric, and probably that's how the industry is going to be changing. No longer will there be endless cities of huge factories, cranking out smoke into the sky, making every little simple dollar store thing that's being made around the world and being sold around the world. But more and more manufacturing factories will be shifting back to our own countries, whether it's here in Japan or many of you guys are in the States or Singapore, Canada, all around the world. Manufacturing is now something that you can do like next to your desk in your office room kind of thing. No longer does it require huge infrastructure, huge factories and armies of people and labor. And so I'm really excited to see how this is going to change the world. What do you guys think about this? Let me know your thoughts. Are you already invested in Desktop Metal? Has this made you start to consider maybe investing in Desktop Metal? Let me know your thoughts, your concerns. Thank you guys very much for your time. Love you and talk to you soon.